Hello hackers! This video will go over the concepts of AES CBC POA Encrypt and how to encrypt arbitrary data. Now, it is expected that you already know how to decrypt data using POA, and if you don't know how to do that, I will link a video in the description for more information on how to do that. I will also link any other resources that I find interesting or helpful to understand POA as a concept as well. Now, without further ado, let's get started. How do we encrypt text in POA? Let's say we have a plain text here. Let's just say it is called "Please give me the flag, kind worker process." Now, if this is the plain text we want to encrypt, this plain text right here can be split up into 3 blocks. If each block is 16 bytes and each one of these characters is 1 byte. So we'll have 3 blocks. The first block we'll call plain text 1, which is the first 16 bytes. Now we have a new block called plain text 2, which is the next 16 bytes. And finally, we have plain text block P3, which is the last 16 bytes, or last however many couple of bytes. Let's just say X bytes, plus any potential padding it might have, because we are using PKCS 7 padding, which will add padding based on how many bytes are missing to make 16 blocks. So let's just say padding. There. So how do we encrypt this into POA? First, let's figure out how it's normally encrypted. So let's go over here. This gets turned into ciphertext blocks. So the first ciphertext block, we'll call it C1. This is equal to the IV XOR, which is this symbol right here, P1. This is how this first ciphertext block is formed. It is formed with an IV that is probably randomly generated by the server, and XORed with the first plain text block. Now that we have this, ciphertext block number 2, C2, is made with C1, XOR, P2. So as you can see, it's using these blocks as a chain, which is the whole point of CBC. And then finally, the third ciphertext block, C3, is made by XORing C2 with P3. And the whole structure of the ciphertext is now IV plus C1 plus C2 plus C3. Hold on. Alright, there we go. So this is how the structure of a ciphertext in CBC looks like. So how do we reverse this? Let's find out. So if we want to reverse this, we'll have to start from the back actually. Because this works as a chain, if we can control this ciphertext block, we can control what we want to decrypt, or we can choose what kind of plain text we want to decrypt to. So let's look at this. So let's say we start, let's say start with any random ciphertext block. So random ciphertext, and let's call it C4. Now, the reason why I say start with a random ciphertext is because we don't really know what the input is going to get decrypted to. Most of the time, it's just going to get decrypted to garbage. That is okay, though, as long as we know what sort of padding error is going on. We can then use that to figure out a plain text reverse encryption, basically. So let's say we have a C4, and C4 should be made like this. We want to XOR, we calculate C4 by saying, let's say C3 is equal to the intermediate value of POA that you do, XORed with P3 right here. To calculate C3, we do the same thing. So we want the next block, which is C2. Oops. C2, which is equal to the second intermediate value. We'll call it, let's say, I prime. XOR this with P2. And finally, for C2, we want to get C1 in this case. C1 is equal to I double prime, which is basically just saying take the intermediate of the intermediate here, and XOR that with P1. So now that you do this process, you should end up with something like ciphertext 1 plus ciphertext 2 plus ciphertext 3 plus ciphertext 4. So notice the structure here. In the encrypted one, we have an IV, C1, C2, and C3. The structure here is a little bit different just for how I use the naming here. But in this case, C1 acts as the IV here. Then C2 would correspond to C1 here. C3 would correspond to C2 here. And C4 would correspond to C3 here. It is completely okay if you do not know the IV in this case, because you can just make it. So the whole point of doing Encrypt is you want to craft ciphertext blocks so that when it is put through the decryption algorithm, it will result in those plain text blocks. So you can start with a random ciphertext block, which will just act as your garbage block to start the decryption process. Then you need to make a ciphertext block here such that the decryption of, let's say C3, for example. Let's pick C3. We want to make a block C2 such that C3 XOR C2 is equal to P3 right here. And then once you have that, just repeat the process for C1 and C3. Sorry, it's a little bit out of order, but do it for C3, C2, and C1. And then you have the whole basically chain of ciphertext that you want to submit here. And once you have built all of your blocks, put them all together and you should have your encrypted message. Now, if this explanation wasn't too clear, first of all, I'm very sorry, but I'll also include some more resources in the description of the video. So if you're ever confused about it, feel free to look at those resources and also ask for help in the Discord. We have a whole bunch of TAs that know how to do this and they will be happy to help you. And that includes me. So yeah, thank you guys so much for watching the video and I hope it helps.